Hello everyone. Welcome back to Dr. Liu's VCE Chemistry channel. Today, let's learn together about the 2024 VCE Chemistry examination. We will focus on questions related to electrolysis and rechargeable cells. Electrochemistry is one of the most challenging sections in VCE chemistry. Another is spectroscopic techniques to analyze organic compounds. My explanations may need to be revised. If any teachers, parents, or students find errors, please feel free to provide your guidance. Blister copper, which contains impurities like silver, iron, and nickel, is refined using electrolysis in an aqueous solution of copper ions to produce pure copper. In this process, the blister copper acts as the anode, where oxidation occurs as electrons are released from the metal. The iron present in the blister copper oxidizes to form iron ions in the solution, leaving no solid iron behind. The pure copper is deposited at the cathode. While iron and nickel in the blister copper also undergo oxidation to form their respective ions, they are not reduced back to their metallic form during the electrolysis. The electrons released from the oxidation of iron and nickel, along with those from copper, contribute to the reduction of copper ions in the solution, forming pure copper at the cathode. Consequently, the amount of copper ions reduced is greater than the amount of copper oxidized from the anode, leading to a decrease in the concentration of copper ions in the electrolyte over time. To understand this question, please visualize an electrolysis cell. The electrolyte in this cell is a sodium nitrate solution. The positive terminal of the power source is connected to an iron electrode, and the negative terminal is connected to a platinum, PT, electrode. Since the positive terminal of the power source removes electrons from the iron electrode, this electrode acts as the anode. Electrons are supplied to the platinum, PT, electrode, cathode, where reduction occurs. In the sodium nitrate solution, both sodium ions and water are available to accept these electrons. By examining the electrochemical series, we observe that water has a less negative, higher, standard reduction potential than sodium ions. This signifies that water has a greater tendency to be reduced. Thus, water gains the electrons, and its reduction half reaction is listed in the electrochemical series. A specific response is required to answer the question. General statements like, "This is a non-spontaneous process," are insufficient. The electrical motive force from an external power supply drives the removal of electrons from iron at the anode and their transfer to water at the cathode, producing hydrogen gas. This non-spontaneous reaction stops when the power supply is turned off, as there is no longer a force to move the electrons. Think of electrical power as an electron pump. The positive terminal acts like the intake, pulling electrons away from the reductant, while the negative terminal acts like the output, injecting electrons into the oxidant. Therefore, during recharging, if electrode X loses electrons, undergoes oxidation, it should be connected to the positive terminal of the power supply. Calculate the mass of leak 6 that forms when a cell is recharged using a 1.25 A current for 1 hour. Follow 4 steps, each worth 1 mark. Calculate the total charge provided. Determine the moles of electrons transferred. Find the moles of leak 6 produced. Calculate the mass of leak 6. In acidic conditions, artificial photosynthesis can produce hydrogen from water by transforming light energy into chemical energy. This process involves the flow of electrons from water to form hydrogen, with light as an electron pump, to drive this transfer. The question asks about the balance of electrical charge, with 2 marks available for identifying 2 key points. This balance is maintained by continuous processes. Electron flow: electrons move from the anode, where they are generated, to the cathode, where they are used, balancing the charge between the electrodes. Ion migration: ions in the electrolyte move, positive ions towards the cathode, negative ions towards the anode, to maintain charge neutrality within the cell. The section on electrolysis and rechargeable cells is worth a total of 13 marks. This includes 1 multiple-choice question worth 1 mark and 1 short answer question worth 12 marks. This 13-mark section represents 10.8% of the total possible score of 120 points. Should you require assistance, please feel free to connect via WeChat or WhatsApp and send an email. Thank you for your attention. Kindly note the details of Dr. Liu's VCE Physics, Chemistry, and Biology channels.